In this video, we will talk about two problems, and I think they are really identical to each other. Here is our first problem, and here is our second problem. The first thing that should come to your mind in this kind of problem is, well, do you use breadth first search or depth first search? And breadth first search is a lot easier. The thing here you have to keep in mind is that for breadth first search, we will be creating a queue, or typically you create a deck. So in Python module, you have an import collection, and we create a deck, and then we append the node into our queue, and then we use the pop left function to pop the leftmost node. If you look at this like hypothetical binary tree, we have 1 2 3 4 5 6 7 blah blah blah, and we start from this one, right? We start from this. We look at its children, we look at the left children and then the right children. If left children is not equal to none, if left child exists, then we add this guy to our queue, and then we look at its right child, and if it exists, then we add this to our queue, right? And then this one will be popped, and our leftmost node for this queue will be 2. Now we need to pop. How many times do we have to pop? We have to pop twice, right? When we are starting at here, we have to pop twice. So we have to come up with a way to count how many times we have to use pop left function. And so that's the key for this kind of problem. And if you look at here, we have 2 nodes in this level, we have 4 nodes in this level, and we have 4 nodes in this level. We have to come up with a way to count how many times we have to pop, and that's using this one. We have a while loop here, and then every single time before we run this for loop, we check the length of this queue, right? So if you initially at here, the length of this queue will be 1, this one will be 1, so we only pop once, right? That makes sense. You pop this one, then our queue will be empty, and then we look at its children. Its left child exists, so we add that to our queue. That's 2. We add this one to our queue. Again, we will be at here, right? And then we have to pop. How many nodes are in our queue? Well, we have 2, right? Current level in this case will be 2, and we pop these 2 nodes. And once we pop this one, we look at its children 4 and 5. They are added here, 4 and 5. And then we pop this one. We look at its children. We have 6 and 7. And we add that to our queue. And then the next one, we'll be looking at this 4, and then we see that we have 4 as our current level, so we pop these 4 nodes, and then we look at these children again. And every time we do that, we create this temporary variable that stores the sum of all these nodes, and then once we exit the for loop, we divide this temp by current level, and then we append that to our answer. And that's for this problem, and similar for the other problem. So let's look at the code for these two problems. Here's my code for this problem, and let's run this together. Okay, so that's for this problem, and then that's for this problem. Let's look at problem 102. And so if you notice, the code is exactly the same. Instead of temp being just that like integer, we will be having an empty array, and every single time we run this, we pop the current level in our binary tree, we add that node to our temporary array, and then once we exit this for loop, we append that to our result array, and we return this result. So this one is exactly the same, at least in my view. And let's run this. So that's for this problem. And if my video helps you guys understanding these topics, please give me thumbs up and subscribe to my YouTube channel. For those in the US, everyone have a great long weekend. And for people outside of the US, I hope you guys have a great weekend. Bye bye everyone, and I will see you next time.